put all of this together and actually do some graphs, do some transformations. So there's a procedure that's recommended by the book. First, we do horizontal shifts. Shifting right, shifting left. Then stretching or shrinking. Finally, well, not finally, next we do reflections. And then finally, vertical shifts. So let's take a look at an example. Now, let's say we have the cube root of x. So what we want to do with this cube root of x, plot this here. We're going to start out with the canonical function. So f of x equals cube root of x. And so it's going to look something like this. Now what we want to do is pick out some basic points here. So we can have 0, 0, 1 and 1, and -1, -1. And what this is going to do as we do our transformations, they're going to be sort of qualitative. This makes them more quantitative. We can follow what these points are doing. So the first thing we're going to do, apply the horizontal shift to the left. Since we have x minus c, or x minus 2, that means we're going to shift, I'm sorry, not to the shift, we're going to shift to the right. We're shifting to the right. So what this becomes, and we do this stepwise. So there's 2. So everything shifts to the right 2 places. Again, when you're doing a horizontal shift, minus c shifts to the right, plus c shifts to the left. So 0, 0 becomes 2, 0. And then 1, 1 becomes 3, 1. And then -1, -1 becomes 2, -1. So we can follow what happens by following these points. Now, since we've shifted this to the right, we're now going to shrink it vertical. So it's going to do something kind of like this. Now, what does this do to our points? Well, remember, when we do a vertical shrink, we're multiplying that y coordinate by that number. So the x isn't going to change. But 1 times 1/2 is 1/2. Here, this one, x doesn't change, but 0 times 1/2 is 0 still. And then this one, the x doesn't change, but -1 times 1/2 is -1/2. And so here we are. This is our final graph. And again, we do it in stages. Let me label what happened here. This would be the cube root x minus 2. And here's the final result, 1/2 cube root x minus 2. So we can do this in stages, and we can follow these points to see what happens. All right, let's take a look at another one. And let's go with cube root again. Well, we'll go with square root. Let's go with square root. So with this one, again, we're going to start out with our square root function. And we can pick some representative points. Say 0, 0. And we could say 1 and 1. And maybe 4 and 2. And it's sort of like how we did when we look at how this is actually working using ordered pairs, comparing the original function versus the new function. So first off, this is square root of x. We deal with the horizontal shift verb. Now this is going to be a plus c. That means it shifts to the left. Minus c shifts to the right, plus c shifts to the left. It's counterintuitive, but at least from an aesthetic point of view. So that means we're over here at -2 for our function. So how does this change your points? Well, now 0, 0 is now -2, 0. This will shift to the left 2 points, or 2 units. So this will become -1 and 1. Remember, horizontal shift will affect the x coordinate. Vertical shift is affecting the y coordinate. And then this, subtract 2, this, 2 and 2. Next, what we do, we're going to deal with the reflection. This is agent x. Now, this could be a little tricky, but what's going to happen? We're going to flip our points across the y-axis. So we have -2 and 0. That goes over 2 and 0. -1 and 1 flips over to be 1 and 1. And then 2, -2, this is going to flip over the y-axis, 2 and 2 to become -2 and 2. So in this case, we can use these points flipping over the y-axis. That's what a reflection does. That means these two will go over here, and then this one will go over here. They'll help us draw that final curve. And there we go. Let's take a look at another. Let's go square. Cute. There we go. So again, let's start with the canonical function. Let's try to recognize it. What it is, we got something cubed. So that means we're going to use the cube function. So first off, we have a horizontal shift. Keep track of where our function is at. So let's take care of that first. So when x is 3, Again, minus c moves you to the right, plus c moves you to the left. And then for vertical shift, plus c does move you up, and minus c does move you down, which we'll see. We're going to shift over to the right 3 units. Well, there are no reflections to deal with. All right. So now we're going to deal with stretching. We have a vertical stretch. Well, actually, it's a vertical shrink. Oh, and I forgot, we should pick some base points here. So let's go with 0, 0, 1, and 1, negative 1, negative 1. So negative 1, negative 1, 0, 0, 1, and 1. Then that means shifting this over to the right 3 units, 3 and 0, 1 and 1 becomes 4 and 1, negative 1 and 1 becomes 2 and negative 1. So negative 1, negative 1, 2, negative 1, 0, 0, 3, 0, 1 and 1, 4, 1. Now we're going to shrink this down by a half. So that means we're going to multiply all the y coordinates by a half. So we're going to get, say, something like this. So what does this do to our points? Pardon me, I did a cube root, and we need to do a cube. So to do something kind of like this. Squish it down. Well, we're multiplying the y coordinate by a half. So y coordinate here is 0, so 3, 0 doesn't change. But this one, 4, 1 becomes 4 half. And then 2 minus 1 becomes 2 minus a half. So 2 minus 1 becomes 2 minus a half. 3, 0 stays the same, 3, 0. 4, 1 becomes 4 half. One more transformation. Vertical shift. So the last transformation, we're going to drop this by 2. So we're going to drop this down by 2. So we have f of x equals 1 half x minus 3 cubed minus 2. So what that does, it takes 3, 0, drops it down to 3, negative 2. 4 half becomes 4 minus 3 halves. Wait a minute, dropping by 2, I'm sorry. Oh, yeah, minus 3 halves. A half minus 2 is minus 3 halves. And then this one here, 2 minus a half now becomes to minus 5 halves. And so this becomes the final result. And again, you can use these points for minus 3 halves, 3 minus 2, 2 minus 5 halves. These points help track what's going on. All right. And that looks like that's going to be it. So if you have any questions, let me know, and I'll get back to you shortly.